And good afternoon. Here's a concept map for Calculus AB free response question from 2008, and this will be question number 6. And again, the disclaimer being this is a concept map. This is not going to be the complete finalized solutions with all the support work that you're going to need to show on the exam. This is just a walkthrough of how to approach the problem and hopefully get you started on the problem and going in the right direction. So let's go ahead and look at what we have here. So number 6, it says let f be the function given by, and then they give you the equation for f for all x values greater than 0, and they even give you the derivative of f already worked out for you. So there's your f prime, your first derivative. For part A, it says write an equation for the line tangent to the graph of f at x equals e to the second power, or e squared. So the big idea for this one, for part A, to write the equation of a tangent line, you need two pieces of information. You need a point and a slope. And you can also use your point slope form. So the slope, where we're going to find the slope at a particular point, that's going to be the job of the first derivative. So you're going to be using your first derivative to find the slope. And at what point do we need it at? We need it at where x is e to the second power. So use f prime for this. So it's going to be f prime of e to the second power, and you'll want to put that into your f prime and calculate the slope at that point. And then how do we find the point x comma y? They're telling you what the x value is, so they said the x value is e to the second. So you'll need to put that into your equation for f. So you're going to use your equation for f and see what the output, or the y value, is. You basically need f of e to the second, and you'll need to compute that. And then once you have your two pieces of information, once you have the slope and you have the completed point, then you want to use your point slope form to build the equation of the tangent line. And let's look at part B. So for part B it says find the x-coordinate of the critical point, so a critical number of f, determine whether this point is a relative min, a relative max, or neither for the function, and justify your answer. So the big idea for part B is that critical points are going to occur where the first derivative is 0 or undefined. So you're going to need your first derivative that they gave you, and determine at what x values it's going to be either 0 or undefined. So for it to be 0, your top numerator would have to be 0, so set your numerator equal to 0 and solve. And for it to be undefined, your bottom, your denominator, x squared, would need to be 0. So determine the x values where the bottom could be 0. That's where it's going to be undefined. Those are going to be your critical values. To determine whether it's a relative min or relative max, the big idea for that is your first derivative test. So you'll want to set up a first derivative test using your critical values, determine whether f prime is positive or negative, and that will tell you whether f is increasing or decreasing. Let's make some room here. So do a first derivative test. For the justification, I've been told that the AP readers don't accept a chart as just your justification. You would want to interpret your chart and say something like, for example, it has a minimum because f changes from, if it's going to be a minimum, it would have to be decreasing. and then it would have to change to increasing to make a minimum. So if you're trying to justify it's a minimum, you would have to say something along the lines of f goes from decreasing to increasing, and you know that because the first derivative changes from negative to positive. So talking about the sign change on the first derivative to justify whether it's a min or a max. And part C. Part C, the graph of f has exactly one point of inflection. Find the x-coordinate of this point. So if it's a point of inflection, that's going to be a second derivative test. So you're going to want to do a second derivative test and find your possible points of inflection. One thing to watch out for, in order for it to be a point of inflection, your curvature actually has to change on function f, so you need to have a sign change in f double prime. So f double prime is going to need to change sign from either positive to negative or from negative to positive. If f double prime is changing sign, then that's going to be a point of inflection. So you want to investigate and make sure you have a sign change at any possible points of inflection to justify that it is actually a point of inflection. And for part D, find the limit of f of x. You could always try direct substitution first. So if you put 0 into the f function, you're going to get an undefined up top, so you can't take the natural log of 0 divided by 0. So probably a better way to think of it would be think about what's happening to the values in the numerator and the denominator as x gets really close to 0 from the right hand side. So for example, if you had the natural log of a small positive number, like maybe 0.001, divided by, again, a small positive number, call it 0.001, what's going to be happening to these values? So if you think of a graph of a natural log, so just looking at this numerator, what's going to happen to this logarithm? So as I get closer to 0, what's going to be happening to the outputs on that natural log statement? They're going to be getting more negative. They're going to become bigger and bigger negative numbers. So you're going to get a negative number up top. Divided by something really, really small. So if that was, for example, 1 over 1,000, so 0.001 is 1 over 1,000. So if you multiply by the reciprocal, it's going to be like multiplying by something relatively large. So it's going to be a negative number up top multiplied by a large number, so call it infinity. And a negative number times infinity should be negative infinity. So that's going to be your limit on that one. And I believe that is all the parts, so that should take care of the quick walkthrough on that. Again, these are not complete solutions. You definitely would need to go back through and do them out and show all the support work to get full credit on an AP exam, but that hopefully should kind of talk about the major concepts and the big ideas behind each of those 4 parts for question 6.